I'm doing problem 10.18, and it reads, we can roughly model a gymnastics tumbler as a uniform solid cylinder of mass, 75 kilograms, in diameter 1 meter. If this tumbler rolls forward a 0.50 revolutions per second, A, how much total kinetic energy does he have, and B, what percent of his total kinetic energy is rotational? So the tumbler has kinetic energy due to 1, the linear motion of his center of mass, and 2, rotational motion about his center of mass. So if we use these equations and then just plug in all the numbers we're given, then we will be solid. So I'm going to use this equation, and then this right here equals 0.5 revolutions per second, which can be converted to 3.14 radians per second. And then I'm going to use this equation, 1/2 mr squared, where r equals 0.5, just given. And then I will be using this, b squared, that's of centimeters, and then of rotational is going to be this. So now that we know all that, to find part A, I'm going to use the total plus the rotational, and then let's see, angular R equals 0.5 times our 3.14, which will equal 1.57. And then for this value right here, I am going to do 1/2 75 times 1.57, and this will equal, I'm going to square that as well because of this equation I stated above, which will equal 92.4 joules. And then for the rotational, for this one, I'm going to do 1/2 mv squared of the centimeters, and I just get 46.2 joules. And then for the total, I add this number to this number, and I get 140 joules. That was part A. Now for part B, to find the percent, it's pretty simple. You just do a ratio of the two. So you do 46.2 joules over 140 joules. So you do the rotational over the total, and you get 33%. So that is both A and B.